Hello everyone, welcome to the Physics by Aryan. So I welcome you all in today's session, and today's session is going to be great for you because in this session I'm going to talk about the revision strategy for upcoming GATE examination. So now GATE exam is in less than 10 days. GATE 2024 is coming up, and the major problem is that there is a lot to revise and we do not have enough time to revise each and everything. So I am going to make 9 small lectures in which in each of the lecture or each of the session, I am going to talk about one subject and what everything you need to revise in that one subject so that you actually revise what is important for GATE examination and you do not revise anything which is not required. And that is something very important if you want to utilize your last 7, 8, 9 days in a very efficient manner. Okay, so today I'm going to talk about the mathematical physics. First of all, I am going to tell you some of the tips which will be very efficient for you to revise. And then I'm going to tell you that in mathematical physics, what are the portions that you should focus on and what are the formulas basically you should revise. I'm not going to tell about each and every thing that you should revise. I will be very, very careful with the formulas. I will give you very precise, very brief, and very to the point formulas that you should revise these topics. That's all. And how much time you have to spend for one subject? Only one day. Because now you have one day for each subject, and that's all. And whenever you are revising, these are the tips you have to follow. Otherwise, what will happen is that you will not be able to complete your revision and the efforts you have put in to cover so much of syllabus will just go wasted. So let's just begin. And now I am going to begin the session with some of the tips that you have to follow. Okay. So what is the number one tip for revision? Revise only those topics which you have already covered. Okay. And also those formulas which are very easy and can be understood in a very quick manner. Okay, you can skip the topics which you have never studied, but in each of the topic I am going to give you some of the formula list that basically will help you, that if you are going to leave the topic you can leave everything but you can just revise those things in that topic. And each of the slide I am going to present you 8 or 9 slides. Each slide will take you just 1 hour. So in one day you have to spend 6 to 8 hours of revision. If you do that effectively, you will be able to complete one subject in one day. So you have the target that for each of the slide I will give 1 hour dedicated study. I will not go beyond 1 hour. Second rule, do not go for previous year questions of so many years. Just revise GATE PYQs of last 5 years, because at this moment you do not have time to revise a lot of PYQs. Because what will happen is that you will just start revising one of the topic and then you will start doing the PYQ questions, and suddenly you will realize that you took 3 to 4 hours just for one topic, and in a day you can only complete two topics. So mathematical physics alone will take you 3 4 days and you do not have that much time. So a very smart student, his strategy is very clear, her strategy is very clear, that only 1 hour for each topic and only the revision of last 5 years of GATE questions. That's all. Not more than that. Because now we do not have time for that. And you have to understand that. And if you are only revising last 5 years, this will give you the best chances to qualify the exam. Your chances to qualify the exam will not reduce if you will not complete all the PYQs at this moment, because anyway you do not have a time to do that. Okay, so first tip is very simple. You have to spend 1 hour for one topic, and second is only last 5 years of PYQ. Next is that you have to write each and every formula with your own hands, and your formula sheet has to be prepared not on the copy pen but inside your head. You should remember each and every formula, you should remember each and every concept, and basically the formulas which are more important I'm going to give you in this session, that these are the formulas that you have to basically work upon, right? There are so much information you might have loaded yourself in the last 6 months, 1 year, but you don't have time to revise each and everything of that now in less time. If you want to revise one subject in one day, then you have to stick yourself to these particular formulas. Just revise these particular formulas, and I'm going to tell you that this 9 sessions, if you watch each and every session carefully for each subject, these 9 sessions will actually help you to get 20 plus marks in your gate examination. So if you are right now at the level of 30 marks out of 100, you will at least score 20 more marks if you will just use this strategy for last 7 to 8 days. Okay, now I want a very good cooperation from you all. If you really want to score 20 plus marks every day, every day, at the end of the day, upload your, or you can send your formula sheet to me, so that I can actually evaluate that how you are doing your in your revision. You can send that in our Telegram channel, which is Physics by Arya. Okay, and if you are facing any problem in your gate preparation, comment down in the YouTube video that what is the problem that you are facing. I will try to address that problem in my next session. Every day I'm going to give one session, and in that session I am going to cover one subject and all the formulas that you need in that one subject. Okay, so revision strategy is very clear: in one day one subject, and one slide means 1 hour. That's it. That is a strategy we need to use. Okay, now let's dig in. So in the mathematical physics topics, mathematical physics entire portion, you can at least expect there will be at least 8 to 9 marks. So 8 to 9 marks are 100% asked from the mathematical physics portion, and this portion is easy to score. However, if you see that 3 to 4 marks are easy, 3 to 4 marks are difficult. But what are how to score these 3 to 4 marks out of your 8 to 9 marks? Or you can even score full marks in mathematical physics, because the question level has not been very difficult except for 1 or 2 years. Other than that, mathematical physics has been very easy subject for gate physics. Okay, so the very first topic in mathematical physics which most of the students miss is spherical and cylindrical polar coordinate system. Now in this basic topic, you have to understand four things basically. Number one, what is the relation of spherical coordinates or cylindrical coordinates with the Cartesian coordinates? If you can do that, if you know the relation between Cartesian and spherical coordinate, or Cartesian or cylindrical coordinate, then you are good to go. That is the number one thing to need. Then, how to write the unit vectors? How to write the unit vectors in cylindrical coordinate system? How to write the unit vectors in spherical coordinate system? That you have to cover yourself. Then the limits of parameters. For example, in spherical polar coordinate system, there are three parameters: r, theta, and phi. What are the limits for that? R can go from 0 to infinity, theta can go from 0 to pi, phi can go from 0 to 2 pi. So you have to decide those limits for yourself. That you have to learn those limits, that what are the limits each of my parameter is taking, so that in an exam you do not make a mistake, right? And the last is curl, gradient, divergence, and Laplacian. How to write curl in spherical coordinate system, how to write gradient, divergence, and Laplacian. Now these four things will just take you 20 minutes, not more than that. Do not distract yourself. I have the free lectures available for spherical coordinate system. I have the free lectures available for cylindrical coordinate system. How can you access these notes? How can you access these video lectures which are completely free for this topic? Go to our website www.physicsbyrn.com. Go to this website, or just search physics by Aryan on Google. You will get our website. Okay, you will see that there is a free capsule course on our website. If you go to the course, there is free capsule course. Okay, so in that free capsule course you will get these lectures completely for free, and you can just go and watch these lectures. Or you, if you do not have time to watch, I would say don't watch the lectures, just read the lecture notes, and these four formulas which I mentioned, just look at these formulas. Okay, so that is for cylindrical and spherical coordinate system. You cannot spend more than 30 minutes on this. The limit is 30 minutes, so 30 minutes is your limit. Okay, so if you are done with this, let's move to the next topic, which is complex analysis. Now, complex analysis is a huge topic, but we have to revise it in a 1 hour. So how do we cover it in 1 hour? First of all, very first thing that you have to see in this is what is analytical functions, and what is the CR condition to find that if this function is analytical or not. For what a condition this will be analytical, for what condition it will not be analytical. So CR conditions per plus analytic functions. Then what are the order of poles? What are the type of order of the pole? How do you find the order of the pole? Right. So there are poles in complex analysis, and you should be able to tell that the order of this pole will be 1, 2, 3, and what is the type of this pole. Okay. So this topic will roughly take you 20 minutes. Right. This topic will roughly take you 10 minutes. Then finding the residues. There are the fixed formula to find the residue for the poles. If it is first order pole, then what is the formula to find residue? If it is second order pole, then what is the formula for finding the residue? You can solve 2, 3 problems and that will help you a lot. Okay. So this is the third formula that you need, and that will also take you roughly 20 minutes. Okay. Then in the end, you have to do two things. One is Laurent expansion, especially for the basic formulas or basically the questions which have been asked in GATE so far, that how to expand any function using the Laurent expansion. If you have never done the Laurent expansion before, you can leave this topic. Do the Laurent expansion formulas only if you have covered this before ever in your life. If you have never done the Laurent expansion before, then you can directly leave this. However, Cauchy residue theorem is something which you can cover in 20 to 30 minutes, and that you should definitely do. Cauchy residue theorem, how to apply Cauchy residue theorem, what is a basic Cauchy residue theorem? And if a very simple question comes from Cauchy residue theorem, you should be able to solve it. Cauchy residue theorem can be asked in many ways, and the question can also be very, very difficult from this topic. But don't worry, you should be able to solve the minimum or basic level questions. If the question is difficult, you can leave in an exam. But at least if the question is coming out to be easy, which is actually happening in GATE exam, that questions from the Cauchy residue theorem are easy. In that case, you should be able to do these questions easily. So these are the 5 things you need to do in complex analysis. So once your complex analysis is done, you can move to the third topic, which is matrices. And this is the most easy topic, and all of you have done these topics many times in your BSc, MSc, many times in your even class 12th as well. So in matrices, first thing you need to know is what are the types of matrices, what are the eigenvalues of each of the matrices. So if it is a Hermitian matrix, how will its eigenvalue look like? How will its eigenfunctions look like? If it's orthogonal matrix, how will its eigenvalues look like? Right. So what are all the types of matrices, and what are all basically what is the nature of its eigenvalues? Then you have to do the properties of transpose. What is transpose and what is its property? What is adjoint and what is its property? What is determinant and what is its property? And what is complex conjugate and what is its properties? So do that, and that is very important. Okay. And then third is eigenvalues and eigenvectors. How to find eigenvalues, how to find eigenvectors, what are the properties of eigenvalues and eigenvectors. And this is a very simple topic, and you must be very much aware of this topic. Okay. Then comes the power of matrix. If I ask you that, okay, this is a matrix, what will be a raised to power 5? Or if I say what will be sine into a is the matrix. So how to find the sine of a, or how to find a raised to power 5? So you have to use the diagonalization trick. So learn that trick, that how you can use diagonalization to find the powers of the matrices. Okay. And in the last, you have to do the rotation of matrices. That what will happen if you rotate the matrix? Okay. So how your matrix will change if you rotate the matrix by, let's say, 30 degree, or if you rotate what is the meaning of rotation of matrix? What do I mean when I say that I am rotating my matrix? So this entire, if you cover this basically 5 points in your matrices, no question is going to come outside that, if it is an average level paper or moderate level paper. Okay. So that is from the matrices part. You can cover it very easily in 40 minutes to 1 hour. If you sit down and you do all of these things, that is very easy. Do not focus on solving so many problems. At this moment, do not focus on solving problems. Rather, at least at this moment, you should try on recalling all the formulas, putting them in the same page, and that's all. Because that's all the time you have. You cannot fool yourself by saying that, okay, I will try to practice 2 or 3 questions of each topic. You do not have the time for that. Okay, good. Then comes the differential equation. In differential equation, 4 things you have to do. First of all, what is linear ordinary differential equation of the first order? Okay, so I should write first order. So you have to find an integrating factor in this case. So what is the formula for finding integrating factor? And once you know integrating factor, how do you use that to find the solution of the equation? First thing is that. Second thing is that how you separate the variables and how you integrate and solve the differential equation. Third, how to do the second order differential equation. Second order differential equation with the constant coefficients. In this situation, you have to find the complementary factor, you have to find the particular integral. So that is very, very important, that you should know that how to find the particular integral, how to find the complementary factor, what are all the rules to find complementary factor, what are all the rules to find the particular integral. If you know these formulas in an exam, you will be able to do at least something. Okay, so in the revision part, you should not focus on questions, but all the rules, all the formulas. And in the last, if it is a homogeneous equation, how to identify that it's a homogeneous equation. What is the identification rule that actually this is your homogeneous equation? And once you know that it's a homogeneous equation, how to solve that equation? What is the rule which is used to solve the homogeneous equation? Okay, so this is your fourth topic, which is differential equation, and you have to do the four topics. This also needs at least 1 hour to cover everything. Okay, vector algebra. That is one of the most important topic, and I can give you in guarantee beforehand that this question will definitely be in the exam. Okay, in that I have put up the four topics which you have to cover. Number one, if I give you any plane, if I give you any surface or any plane, what is a vector which is perpendicular to that surface? That is the first thing. What is the surface which is parallel to this surface? So let's say I have some surface like this, I have some curved surface, and I am asking that what will be the surface which is parallel to this surface at this point. So that is the second formula you need. Third is how to write gradient, how to write curl, how to write divergence, and how to write Laplacian. And you need this in all the coordinate systems, not just in uh, Cartesian coordinates, but also in spherical and cylindrical coordinates. Okay, what are the applications of curl and divergence? All of that. So basic ideas. Okay, and then double derivatives. That what will be the curl of curl? What will be the curl of divergence? What will be the divergence of let's say curl? All these things. So there are 6-7 rules of double derivative. So it will roughly take you 5 to 10 minutes to revise that. So you can actually do all of this in just 30 minutes because this is very simple. You just need the formulas of this, right? And most of you have already been studying these many times. You have covered this in BSc, you have covered this in MSc, you have done the multiple courses of mathematical physics, and every mathematical physics course starts with this. Okay, so that is another idea. Okay, now next topic is vector calculus. Now in vector calculus, this should take you roughly 1.5 hours, roughly 90 minutes, because this is an important topic and this is crucial topic. And this topic is difficult. In that topic, first of all, you have to understand what is line, what is surface, and what is volume integration. How do you write line integration? How you write the surface integration? And how do you write the volume integration? When you are writing the line integration, you have to write the line element. And line element is different in Cartesian coordinates. Line element is different in cylindrical coordinates. Line elements are different in your spherical coordinates. Similarly, surface elements and similarly volume elements. So you have to understand that in all three coordinate system, how to write line elements, surface elements, and volume elements. If you go to my lectures in free lectures in the free capsule physics course, you will be able to see that there are the notes on cylindrical and spherical coordinate system, and in that I have discussed in detail that how to write the line, surface, and volume elements. Okay, then how to write the integration of the limits, integration limits. Your integration will go from which limit to which limit, so that in an exam when you are doing the integrations, you should be able to do that what should be your limits. Okay, then in the last you have to understand basic questions of Stokes theorem, Green's theorem, and divergence theorem. What is the basic derivations of these? Not derivation, the basic formulas for these three theorems, and what is basically going to be the very basic questions of these three theorems. Okay, so If you cover these four things in vector calculus, you are good to go, right? In an exam, you will be able to use your brain and you will have the enough formulas to solve the questions from vector calculus. Okay. Then comes the special functions. Now, this is something if you have never covered before, you should at least do it again, because it will roughly take you 1 hour and you have to just memorize few things. What are the things you have to memorize? First thing is, which is basically logic based thing, that how to find the singular points or regular points. So sometimes an equation is given to you, which is basically the second order equation, second order differential equation, and you have to identify that if this point, any point, let's say x equals to 1, is a singular point or a regular point, if it is an ordinary singular point or if it's an ordinary not ordinary. So ordinary, not ordinary, singular, regular, all these things you have to identify. So you can read HK Das book, just a one first page of that, and that topic is very much clearly given there and you will be able to identify this. Okay. Then you have to do Bessel, Legendre and Hermite. If you are a student of physics by RN, then you have a notes for this. You just have to revise those notes thoroughly. Each and every formula that is being given to those notes, you have to do it. But if you are a student of any other coaching or if you are doing the self study, if you have the notes, revise it. But I will not suggest you that if you have never revised it before, if you have never learned that those formulas before, do not try to do those at this moment, because these are so many formulas and that will just confuse you. Okay. However, if you are a student of physics by RN, we covered this in detail and you just need those slides and you just have to revise those slides. Okay. So that's all for special functions, and these questions are coming from last 2 years. Although this topic was not very important initially, but now from last 2 years, GATE is asking the question from special functions. Okay. Then come Fourier series. Fourier series I have put, but it's not a very important topic. If you are not good with Fourier series, you can leave. But usually what happens is Fourier series we have done so many times that it is very easy topic to revise. So basically we have to revise what is the formula for A naught, what is the formula for AN, what is the formula for BN. Similarly, how the AN formula A naught, AN, BN becomes for odd functions and what happens with the even functions. So if you have an even function, what will be the value of A naught, AN, BN? Or if you have an even function, similarly, what will the values? How to identify that if it's an even function or odd function? Especially from the graph. If I give you the graph and I ask you that will this function be odd or even, you should be able to tell. Okay. Then the last term which comes is what how to write the complex Fourier series, how to write the half range series, and in the end Parseval's formula. So these are the things that you have to revise in the Fourier series. But I will say that you can keep Fourier series in the end because it is not a very important topic for GATE examination. Okay, good. Then comes the Fourier and Laplace transform. In Fourier and Laplace transform, do not try to go much in detail. Just do the basic formulas of transform. That what is a basic definition of mathematical definition of Fourier transform, what is a basic mathematical definition of Laplace transform. What are the properties of Fourier and Laplace transform? Simple properties. There are 4 or 5, 6 properties for both. Just do that. And in the last, you have to see that what is the transform of delta function. What will be the Laplace or Fourier transform of delta function and what is the Laplace or Fourier transform of Heaviside function. One more function that you can add here is basically Gaussian function. So you can even look at for the Gaussian function. That will also help you. Okay. So for these three functions, what will be the Fourier transform? Similarly, can you define Laplace transform as well? Okay. And one more thing which I should add here is what is the relation between Fourier transform and Laplace transform? There is a relation between Fourier transform and Laplace transform. You should be able to see that how what is the formula between them, relation between them. GATE has asked this question, okay, and they can ask again because GATE does repeat their questions, okay. So that's all for your mathematical physics part. If you revise this much formulas, then you are good to go with the mathematical physics, okay. Now in the comment section, let me know that what are your weakest topics, and I will try to put the notes or I will try to put the videos for that so that you can very quickly cover that topic. So which you think that it's an important topic, especially for, so let's restrict ourselves for mathematical physics. So tell me two things in the comment section. First of all, that for all these slides, for which of the topic you do not have the formulas, so that I can provide you the formulas which you can revise very quickly. So let's say you do not have formula for special function, then mention in the comment section that I do not have formula for special function. I will provide that. Okay. And also tell me that which of your subject is weakest, so that I also provide a good resources for that. Okay. So that's all for today. I hope that this video you enjoyed. If you like this video, you please subscribe to our channel as well. Only reason for that is that you keep connected with the physics fire. Okay. And on the exam day, on the gate exam day, we will take the live session on the exam day, and we will solve the entire paper based on the students memory based questions. Okay. And I hope that your gate exam goes very well. So that's all for today. I will see you in the next session about the classical mechanics. That's all for today.